what if we want to build a system which can learn incrementally from stream of incoming data like stock price prediction or click-through rate or every search you do, because data is flowing. It is not stagnant anymore. The search you do, the click you do, everything, even a single dot that you do on the internet is our data today, and it cannot be missed, it cannot be left, because it has the pattern. And you want to make a system that can learn incrementally based on the input or based on the data it is being fed. Okay, now in machine learning we classify machine learning uh, in a criteria whether it can learn incrementally or not. Okay, so we have two ways so that our system can learn incrementally, okay, from the streaming data or the data which is incoming. The two ways are online and batch learning. Okay, now the first thing that we have to talk about is batch learning. Now in batch learning, the system that will build in batch learning will be incapable of learning incrementally. Okay, now hey, what I said right now, that we want to build a system which can learn incrementally, and what I'm saying that it cannot learn incrementally, let me tell you. Okay, so if we want to train the model, if we want to train the system and using batch learning, then we'll have to train it using all the available data we have. It should be trained with all the available data. Okay, available data, it should be trained with all the available data we have, and it takes a lot of time, okay, a lot of computer power, okay, computer resources, okay, and so it's done offline, because it cannot learn from the incoming data. Suppose that the water is following and you want to pour some water, you cannot directly pour water from the stream. Okay, suppose this is a river and the water is following, you go there and you have a pot, or you have a utensil, so that you can pour water and collect and drink it, or whatever the use case of it. You cannot directly do with this method. What you can do is that you let the water to be still and then take the water from it, because the water is not following. Same the case is here. In the batch learning, we cannot actually use the data which is directly incoming and it is updating like per second, or if it is updating secondly. What we can do is that the data we have, suppose the data we have got an hour ago, we can use the data to train the system. Okay, and we do it offline because it takes a lot of memory, it takes a lot of computer resources. Okay, then what we do is that once it is trained, then it is sent into the production. Okay, it is trained, it is launched, then it is uh, sent into the production. Then it knows only those things which it has been trained on. Okay, now it do not know anything about else which is coming. Okay, so we often call it as offline learning because it is done offline. Okay, it is not done using the streaming data. We take the data, then we gather it, we use it, then we train it, and then we make a system in it. Okay, now the whole process, okay, the whole process takes a lot of time, because we need to have a new data. Okay, then we need to have new data, then we have to feed the model our then we have to feed our model again. Suppose this is the data, this is the model, and we got our output. Okay, we got our output. Hey, we are done for the today, but what about tomorrow, or what about the next hour that the data will get? We'll need to again feed the data to it. Okay, feed the data to it, and we have to again retrain it, which costs a lot of money. Okay, because we cannot afford to train it again and again and again, because it costs money and it is not actually financially or feasibly good. Okay, so this is what batch learning does. And there are a lot of things, that it takes, and it is not actually good if we want to if we want to have change very rapidly. It is not a good way to use batch learning. Okay, so we know that batch learning, it is done offline, and it takes a lot of compute power. But hey, why are we actually using it? Because if we want to learn from incremental data, it does not mean actually that it is coming every second. Okay, incrementally doesn't mean every second. It could be interval. It could have an interval of an hour. Okay, it could have an interval of an hour, 30-minute, daily, or monthly, okay, that could be the case. That could be the case. Okay, now the compute resources, does it takes, it takes a lot of CPU, it takes a lot of memory and disk space, or like simply you can say that the uh, RAM. Okay, it takes a lot of power. That so if we want to train on a very large data set, is it possible, or will it be a good practice to use batch learning on it? No, not definitely no. Okay, now where do we use batch learning? We can use it on a system that is changed monthly, or we have to report monthly, like a monthly example, monthly sales report, or for example, monthly rent collection. Okay, or whatever the case, that the data which is the data we have to train on, like a good time period, like a week, or a month, or a 6 month, or a year. That's where batch learning can be used. But hey, it takes a lot of space, it takes a lot of computational power or resources, so will not go to it, because it is very costly. And we don't want our money to be spent on this only, and not on the other aspect of the business, because machine learning is all about making your business good. You're making your business easy and more profitable and systematically. Okay, this is what. Now the second way, it's online learning. So hey, is it done online, or what it is? That does it have any online profile or something? No, not like that. So we want to train the system incrementally by feeding the data individually, or we can feed it sequentially in a small groups, or which is called as mini batches. Okay, so what is done in online learning? It is same as batch learning, but what we do actually is that we give it data. Okay, we give the data in very very small groups. Okay, small small groups called mini batches. Okay, mini batches. Okay, and it adapts very quickly, because the model we have, and the data we feed, and the output we get, and we feed data. Okay, we feed data as rapid as possible, and it shows the change very rapidly. Okay, it shows that change very rapidly, and it is very great. Okay, and online learning is very great for the system that receive data as a continuous flow. Okay, the data which is flowing continuously, and that need uh, that need to adapt data, that no sorry that need to adapt to change quickly. Okay, quickly. For example, stock price. That's where online learning comes. Okay, now in online learning, we do not need to train it on with the older data. Okay, what we used to do in batch learning is that we had the older data. Okay, we have trained our model in it. Now we have to train our model on the old data with this new small data, and we have to train the whole data available to us, and which makes it very hectic, or which is not a very good practice. You can do it, but still it is not a good thing. Now, online learning, it is very cheap, okay, and very fast. It is very cheap and very fast because we are using mini batches, or we are using small groups of data, and we feed it and we train on it. Okay. Okay, simple as that. Now, what if the data is so huge? Okay, if the data is so huge and it cannot be trained on the main memory. Okay, the main memory is not that capable of training the instances, okay, the data. Then what you do actually, that we simply, what I'm trying to say is that mm, the online learning algorithms can also be used to train the systems. So they train the machine learning systems on the very huge data set, which cannot fit on one memory, okay, which cannot fit on machine's main memory on one memory which it has, okay, and it's called as out of core learning. Out of core learning. So what is out of core learning? Out of core learning is nothing but using online learning algorithms to train machine learning systems on huge data set which cannot fit on the machine's main memory. Okay, simple as that. Okay, now, so as in online learning, how is it trained? Does it train online where it is just being trained and we are feeding it? No, no, no. It's also done offline. Yeah. So is it confusing or what? Like, is it done offline and we have been told it is done online? So what is the confusion between the names? So there is actually no any confusion between the names. Uh, online learning, online learning is actually done offline. Okay, it is done actually offline. So we'll call it as incremental learning. Okay, it's also called as incremental. Sorry for the spelling. Incremental, incremental learning. Okay, incremental learning. So what matters in online learning is learning rate. How fast do we want our model or our system to change, or how quickly we want to adapt? Okay, so there is a term called learning rate. There is a term called learning rate. So what it does is that it tells the system to how quickly does it need to learn. Okay, how quickly will it learn? Okay, simple as that. So if the learning rate LR is high, okay, then it will adapt. The changes it will adapt will be very rapidly. Sorry, yes, adapts will be very rapidly, but it will forget the old data, because we are feeding new data every time. So it will forget the old data which it has been trained on. Okay, and what if our learning rate is low? So it will adapt very slowly. It will adapt slowly, and it will only remember. It will only remember. It will only remember the old data, because we are training and it is adapting very slowly. So it does not actually know what it is being fed. Okay, so that is the case. Now another thing, we have the challenges that we get in online learning, because it is very fast, it changes very rapidly. So the problem, or the thing that we face here, is that if bad data if bad data is fed if bad data is fed, it will show it will the performance will go the performance will decline. Okay, if data is fed bad, performance performance will decline. because the online learning, what is done is that it at the same time it is being trained and it is being on the production. Okay, it is on the production. So if we give it bad data, its performance will go down, it will decline, and the customers or the clients, they will notice it on live. Okay, they will notice it. Okay, and for that we need to monitor the data, and we have to care about the data, and we have to react, or we have to know about, or everything that we do to make sure that data is good, or the data is a quality data and is not some data which is very cliche, or which does not actually make any sense to the model. So we have to care about that. And that's all online learning is all about. It's mainly about that. It's about making a system that can learn incrementally, that can learn incrementally, and using okay, very less computational resources and all. Okay, and the only disadvantage or challenge we can have, not a disadvantage but the challenge we'll have, is that it will that it will its performance will decline. Its performance will decline if fed if fed bad data. If fed bad data.